And in today's video, we are gonna go over the physics of flying. The White brothers would be proud of what I'm about to say. Wait, is it the Wright brothers? I don't know. I didn't learn about that in history. But okay, let's see. Okay, before I start, I'm kind of scared of flying. Yo, have you ever had like those like dreams where you like no one's flying the plane, right? But then you step in and then you land the plane. Why do I feel like I could land the plane, even though I know I can't? I don't know. I play too many phone flying simulators. I don't know. I just feel like just give me that boy. It's like I don't know. But okay. So the four forces, the delicate equilibrium that keeps a 400-ton machine in the air. How come I can't fly, bro? Okay, so first of all, you need lift. So this is the upward force generated by air moving over the wing. That's opposing the weight of the aircraft. Weight is the downward pull of gravity. To stay level, lift must be equal to the weight of the plane and thrust, and that is generated by the engine to propel. Oh, I'm gonna move it over a little. Generated by the engines to propel the aircraft forward, overcoming the resistance of air drag. Hmm. What are the chances I get? Yo, do you know those like flight simulators? Why do I feel like I want one for my house, just to like I don't I definitely won't know how to use it, but like, is it like a beginner mode? I don't know. So in the air, the air acts like a fluid. So this is the fluid dynamics basics. So to understand flight, we must treat air as a fluid, and it has mass, density, and follows the law of fluid motion. So first we have continuity. So air flowing into a restricted space must speed up. Also, viscosity is the thickness of air creates friction against surfaces. And next we have streamlines of path traced by air particles moving smoothly around an object. Uh, Wind tunnel diagram showing smooth airflow over aerodynamic shape. Yeah, you would see that, but then Jerry just decided not to put it in. He's still in Fiji, so maybe that's why his Wi-Fi like isn't the best right now. I don't know. When is Jerry? Should I text him to see when he's coming back? He never told me. He did bring 4 luggages. I'm like, why? Like for a 2-day trip, I just brought a backpack. I'm not gonna lie. Like I don't need. Like the backpack was even a little too much. Okay, so we're gonna do a deep dive into Bernoulli. So he talks about how pressure differences create the magic of lift. Okay, so he's okay. Just no. Okay, pressures versus velocity. So his principle is as the velocity of a fluid increases, its static pressure decreases, and wings are designed as airfoils to take advantage of this. So we have this little equation over here, but the curved top of the wing constricts the air, forcing it to speed up. This creates low pressure above the wing and effectively sucks the airplane upwards. I remember when I was like 8, I used to think about how do airplanes work, and I watched this one animation. I was like really fascinated by it, and then I was thinking about, do I want to be a pilot? But then I realized I'm scared of planes. So, yeah, that might be a no for me, guys. Alright, sorry I had to pause it. I had to go scroll for 50 minutes, but I am back, and now we can talk about pressure differentials. Yeah, I'm gonna go back scrolling. Oh, pressure differentials, really? Well, anyways, so the force of the atmosphere, so even a small difference in pressure, less than 2%, across a massive wing area creates enough lift to lift a 4747. I don't know why I don't believe that. 2%, there's no way. So if I create a pressure differential across my arms, do you think it will lift me? But for example, A pressure drop of even 1.5 psi over 5,000 square feet wing generates over 1 million pounds of thrust lift. Damn. Okay. The anatomy of an airform. So optimizing the shape. So engineers design wings with specific geometric features to match. Sorry, it's a little cut off. Geometric features to maximize efficiency. So first off, leading edge. So the round front that splits the incoming air. Second, the trailing edge, which is the sharp rear end where the top and the bottom flows meet. Now the chamber. The curvature of the wing surfaces and chord lines, which is the straight lines connecting the front and the back tips. Look at this little picture. Also, have you ever guys tried Haiti? Like, I went to New Jersey, right? Ow, shoot. Yo, I hurt myself with a tape measure. Anyways, have you ever tried Haiti? I should have tried it when I had the chance. I don't know why I didn't. I don't know. It didn't look like they took cash or anything. So, I don't know. There's Molly tea, Haiti. Like, what's the difference? It's just tea. Maybe I don't understand. I don't know. Okay, so we're gonna move on. So we got lift versus angle of attack. So we have 5 to 20. So at 20, you stop. Yeah, we don't want to do that. So the angle of attack is the angle between the wing and the wind. If it is too steep, the airflow separates, causing a sudden loss of lift called a stall. So as you can see, 15 degrees is the max. It gives you max lift and potential. But 20, that's yeah. So we're gonna want to avoid that. Haiti. I don't know. I was just scrolling and I was looking at it. I was like, huh, that reminds me of when. Yo, I hurt my finger on my tape measure. How do I do that? Alright. So we're gonna talk about evolution of wing design. So in 1903, it was a thin, highly cambered, biplane structure for stiffness. But in World War II, it was a metal monoplane and a reduced drag and skin made out of metal. But then the jet age, there was swept wings with handling high-speed shockwaves, and finally the modern is composite winglets with vortex reduction and fuel efficiency. Wow. Oh, is that a private jet? Hold on, let's move over. Ho, that is a private jet. I'm gonna get that one then. I'm gonna just buy it. I don't know, why is it so expensive though? Like, where's teleportation gonna be invented? Oh, shoot. Yo, that happens every video. I promise I'm not scrolling. Wink, wink. Yeah. Oh, look at the cute ducky. Okay, I mean, my bad. So modern winglets at the tip of every right here, high pressure air from below tries to curl over the low pressure zone above, and this creates a swirling vortex. So these vortices create significant induced drag, and modern vertical winglets acts as a barrier diffusing the vortex and increasing fuel efficiency by up to 5%, saving airlines billions of fuel costs every year. I'm gonna buy this private jet. Trust me, trust me, trust me. Oh yeah, I saw a video of a video about if you should add winglets to your private jet, and they were talking about like if it's short. They were saying how even though it saves you on fuel efficiency, it adds like 400 pounds, and that adds fuel cost. So it's only worth it if you go over a certain amount of miles. And I'm gonna need to know that because I'm gonna buy a private jet. But anyways, any questions? Thanks for exploring the invisible forces of flight, and I hope you enjoy planes. I'm still scared of planes, so yeah. Anyways, oh shoot, this guy's at what? Oh, huh. Anyways, here's the image sources. And yeah, I hope you have a good day, and I hope to learn something. I'll see you in the next video. Bye.